Hello everyone, welcome to this video. In this video, we'll be looking at another question from IIT-JAM Mathematical Statistics paper 2020. Right? This is an MCQ question and this is a 1 mark question. So here in this question, they are saying if you are given a system of linear equations, this system of linear equations is given to you, then which of the following statements is true? So they are saying whenever we have these particular values of A and B for 4 different given options, 4 different values, then it would have either unique solution or no solution or infinitely many solutions. So which among these is correct? So obviously this is the MCQ question, so only one option is going to be the correct option here. So and moreover it is a 1 mark question, so what we can do, we can just substitute the values and see whether we could knock off some of the options and then get back to the solution. So let's start. So for the solution here, if we may write the system of equations. So let me rewrite the system. It is ax plus 2y plus z is equal to 0. Then y plus 5z is equal to 1, that is given to us, and moreover we are given by minus 5z, that is equal to minus 1. So we could convert it into the corresponding matrix form. So its matrix form is A augmented B matrix, and this is equal to the matrix where the coefficient of x is A, coefficient of y is 2, then z is 1, and the right hand side is 0 for the first equation. For the second equation we have x as 0, y as 1, z as 5, right, and the right hand side is 1. For the third one, x is 0, y is b, z is minus 5, and the right hand side is minus 1. So this is our matrix A augmented B. Now you should note that when can we say we have a unique solution or no solution or infinitely many solutions. So in the first case, I would say unique solution would exist. For unique solution, we should have the rank of matrix A equal to the rank of matrix A augmented B, right? And moreover, this thing should be equal to the number of unknowns. In our case, the number of unknowns, they are 3, right? So if that is so, we have a unique solution. When do we have infinitely many solutions? So we have infinite solutions whenever the rank of A is equal to the rank of augmented matrix, that is A augmented B, right? But this is lesser than the number of unknowns. If that is so, we have multiple solutions with us. And when do we have no solution? In the third case of no solution, whenever the rank of matrix A that is exactly not equal to the rank of A augmented B matrix. So this is the result that you should note. Now using this results, and we'll be applying different cases to this matrix here. So let me mark this as star, equation star. So let's one by one substitute the solutions. So for option A, we have the value of A as equal to 1 and B as equal to minus 1. So let's substitute, and we have to check for unique solution, right? So in the first case, we have the value of A as 1 and B as minus 1, right? So our augmented matrix would become, it is 1, 2, 1 and 0. In place of A we have substituted 1, and then the second row would be as such. For the third one, in place of B we have to write minus 1, right? So now we have to see for this matrix what is the rank here. So you see clearly that for R3 this is perfectly fine for the echelon form. We'll see the rank using the echelon form. So when you apply on R3 the function R3 plus R2, because here we wanted to make this thing as equal to 0, right? So we can add row 3 and row 2 here, so that it would be 1, 2, 1, 0. It would be 0, 1, 5 and 1, and this is 0, this is 0, this is 0 and this is 0. So you see clearly we have 2 non-zero rows, so as there are 2 non-zero rows in the echelon form of the matrix, Therefore, what is the rank here? The rank of matrix A, that is equal to the rank of matrix A augmented B, right? And it is equal to 2, right? And this is less than 3, the number of unknowns. So obviously in this case we would have multiple solutions. So they in the first case are asking for unique solution, so that means this option is incorrect, right? So we would say this option is incorrect. So let's now move on to check our second part. For the second part, they are saying A is -1 and B is equal to 1. So let's have a look here. So A is equal to -1, so this is going to be -1, 2, 1 and 0, right? The next is 0, 1, 5 and 1, and the next one is 0, 1, because B is 1, -5 and -1, right? So here again we wanted to first of all make this element as 1, so we can apply the row operation here. On R1 we apply R1 multiplied with -1, so that your matrix now become 1, -2, -1 and 0. The rest two rows, they would remain as such, no change in them, right? Now after that we wanted to make this element as 0 using the second row. So here we'll apply the operation that apply on R3, the operation that R3 minus R2, so that you would have the matrix as first row would be as such, the second row would be as such, right? And for the third one it is 0 minus 0, 1 minus 1, -5, that is -10, and then you have -1, that is -2. So clearly in this case, rank of A, that is equal to the rank of A augmented B, and that is equal to 2, right? As both of them are equal and lesser than the number of unknowns, which is 3, therefore in this case we would have, it is 3 not 2, right? Why? Because in this case we have 3 non-zero rows, so the rank here is 3, and it is then equal to the number of unknowns, which is 3, right? So we have a unique solution in this case. So if we have a unique solution in this case in B part, so that means this option is correct, B option is correct. They are asking for unique solution for these cases, right? So for the sake of completeness, let me also tell you why option C and option D, they are incorrect. So here for option C we have the value of A as equal to 1 and B as equal to 0. So let's solve this one. For the C part, we have the value of A as equal to 1 and B as equal to 0. So A is, we have the matrix 1, 2, 1, 0, right? The next would be 0, 1, 5 and 1, and the next one would be 0, B is also 0, right? -5 and -1. So here in this case they are asking for no solution, right? So we have to convert this into echelon form. So clearly this is in echelon form, no change in this one. Here the rank of A, that is equal to the rank of the matrix A augmented B, and that is equal to 3, right? So in this case we would have unique solution. So that means this is an incorrect option. So this is an incorrect option, right? So we would cross out this option here, and for the last option D, here they are saying A is also 0, B is also 0, and they are asking for infinite solutions. So let's head back to solve this D part. For the D part we have A as 0, so we have 0, 2, 1 and 0, then it is 0, 1, 5 and 1, and it is 0, 0, -5 and -1, right? This is our matrix here. So for this matrix, we wanted to make this into echelon form. So the first non-zero entry in the first row, that is 2. So first of all, let's make this as 1. So we have to apply the operation on R1, that we have to divide R1 by 2, right? So that we would have 0, 1, 1 by 2 and 0, right? And the rest 2 rows, second and third, they would remain as such. Next, what we wanted to do before, after making this as 1, we have to make all the others here in this column as 0. So we have to make this as 0. How we can do that? So on R2, we'll apply the operation that R2 minus R1. So that we would have the first row would be as such. The second one, it would be 0, 0, right? 9 by 2 and 1. And the third one would also be as such. Next, what we wanted to do, we wanted to make this element as equal to 1. So what we have to do here, we have to multiply this row 2 by 2 into 2 by 9, right? We have to multiply this by 2 by 9. So your first row would be as such. So it would be 0, 1, 1 by 2 and 0. Then it is 0, 0, 1 and it would be 2 by 9. And the next one is 0, 0, minus 5 and minus 1. Right? Next, what you wanted to do, you wanted to make this element as equal to 0. So how you can do that? In order to make this into echelon form, you just have to apply this operation that on R3, it is R3 plus 5 times of R2. We have to make use of second row only. So that it is equal to 0, 1, 1 by 2 and 0. Second one would be as such, 0, 0, 1 and 2 by 9. And the third one, it is 0, 0, 0 and 1 by 9. You can check your calculation here. So you see, in this case, we have the rank of A as equal to 2, the rank of A augmented B matrix, that is equal to 3. So in this case, rank of A is clearly not equal to the rank of A augmented B. So in this case, we would have no solution, and in the option they are saying for multiple solutions. So therefore this option is incorrect, right? So you see how option C and option D, they are also incorrect. So we only have B as the correct option, right? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.